Hassler here. I'm going to give you notes on 1.5. So in class, we had done some practice problems using some slides, and then we talked about combining like terms in the distributive property. Make sure that you get these notes down as you can use your notes on the quiz. If you have questions, make sure you ask your teacher. So I'm going to break this up into 3 sections, and this first section is going to be combine like terms. And oftentimes, that's an M, there you go. Oftentimes you'll hear your teacher say CLT for combine like terms. So this should hopefully be a review for you from middle school, but let's go through a couple examples just to make sure we're feeling confident. So my first example is 3n minus 4 plus n. Like terms are terms that have items in common. So for example, the 3n is a like term to the n. And by the way, because there's no number in this second n, it's technically a 1. And so I like to draw the 1 in to remind myself that I have 1 n. These are like terms because they both have an n in them. And so what I'm allowed to do is I'm allowed to combine these two terms together. 3n plus, I'm going to use the sign in front, 1n gives me 4n. Because this minus 4 does not have a term that is common to it, meaning there's no other term with an n, without an n, I simply just rewrite the minus 4, and then I'm done. Let's do another example. So in my next example, I'm going to have 7x squared plus 20x minus 6x squared plus 9x. Okay, so again, I want to combine terms that are alike. I noticed that all of these terms have an x in them. It's just that some of the x's have an exponent. And so if x has an exponent of 2, that is technically different than this second term where x does not have an exponent. So I'm going to circle them in different colors. Yes, they both have an x, but this x squared really means that I'm multiplying x times x. There are 2 x's being multiplied together, whereas this x without an exponent means that there's only 1 x as part of that multiplication. And so the terms are different. In the first term, I have 2 x's being multiplied. In the second term, there's only 1 x being multiplied. All right, so this negative 6x squared has an exponent of 2, so it's going to match the 7x squared. That's why I circled it in pink. Notice that I also circled the sign with that. That's going to tell me that I have to do 7 minus 6, which is 1, and then I'm going to rewrite the x squared. I'm counting how many x squareds there are. And after I do 7 minus 6, I have 1 x squared. I'm going to circle the plus with the 9. So whatever sign is in front of the term, you keep the sign with that term. And now I have 20x plus 9x, which is a 29x. I'm just going to leave it as x. I'm counting how many x's there are, and there are 29 of them. Okay, so that's combining like terms. The other thing that we are reviewing is the distributive property. And when we talk about distributive property, we are talking about the fact that there is a number, I'm going to call it 2, directly connected to parentheses. So I have 2n plus 6. Now in the combine like terms examples, I didn't have any parentheses. So this looks a little different. When I have a number directly connected to or in front of those parentheses, that tells me that I'm going to complete the multiplication operation. So distributive property means to multiply. Oops, I got to spell multiply correctly. Let me try that again. There we go. Okay. So I'm going to multiply. What that means is that I'm going to take this 2 and I'm going to multiply it to the n. Now remember, there's technically a 1 there. It's like saying I'm going to do 2 times 1n. And then I'm going to take the 2 and I'm going to multiply it by the 6. I'm going to do 2 times 6. So you can write underneath the 2 multiplications that you're going to do. You could draw arrows like I did to claim that the 2 gets multiplied to each term. It doesn't matter how you approach it. You just have to keep in mind that this number in front is going to get multiplied to each term inside. So 2 times 1n is 2n, and 2 times 6 is a positive 12. And so that would be our final answer. I want to do another example, and this time I'm going to have x parentheses x minus 4. All right. So again, this x is going to get multiplied to each term inside. That's like saying that I have x times x and x times negative 4. So again, you do not have to write that multiplication underneath, but for some people it's helpful to show, hey, this is the multiplication I have to do. The x on the outside gets multiplied to each term on the inside. Now, let's take a look at this x times x. Over here, I had mentioned that x times x represents x squared. So let's write that at the top. X times x means that 2 x's are being multiplied, which is x squared. Versus x plus x means that I have 2 x's being added together. And so there is a difference between x squared and 2x. So let's get that at the top. X times x is x squared, whereas x plus x is 2x. So I have x times x, that's x squared. And then I have x times negative 4. So notice that negative, that subtract in front of the 4, is going to be part of that multiplication. And 1 times negative 4 is negative 4, and that x goes with that term. And this would be my final answer. They are not like terms because one has an exponent and the other does not. So I want to put it all together. This is a multi-step. And so I'm going to have 2x minus parentheses 6 minus 9x. So this has a couple of things happening. The first thing I notice is that there's no number directly in front of my parentheses. And so if that's the case, I'm going to put the number 1. We also have to consider order of operations. The first thing is that 2x and negative 1 are not like terms. So I cannot say 2x minus 1 and make it a 1x. They are not like terms. But the other thing is order of operations is PEMDAS. Parentheses, exponents, multiplication or division, which comes before addition or subtraction. So I'm going to circle this negative 1, and I have to multiply before I can do anything with that 2x. So I'm going to rewrite the 2x. I can't do anything with that yet. And then I'm going to write what I get when I multiply negative 1 times 6, which is negative 6. And then negative 1 times negative 9. Negative times negative is a positive. 1 times 9 is 9x. And now I notice that I have some like terms, 2x and 9x. And so when I combine those, I get 11x. And then I still have that minus 6 left. So sometimes I have to do multiple steps. I have to distribute and combine like terms in the same problem. If you have questions, make sure you ask your teacher.